Good morning, everybody. Today we're going to be working on all types of money problems. We did this in chapter 7. We worked on all different types of ways you could take loans or have a bank account. And again, we did that the long way because we were only in chapter 7 exponents, where we did a lot of plug-in and he had to follow the order of operations to get the answer that we needed. So now we're going to do questions that are very much the same, but we're going to use logarithms and we're going to do them a whole lot quicker. And I think they're going to be a whole lot easier. Before we begin, we do have to go back over our exponent equations. Now, you definitely need to freeze this and either print out this one little piece, like take a screenshot, or you should write down notes. Very important. Let's talk about exponent equations. So exponential equations, the most basic, y is equal to ab to the x. Now, this is one that your calculator will use when we, in a few weeks, do regression equations where we input data and the calculator gives us the equation. You've used this with graphing. We use this all throughout chapter 7. This is the initial amount. This, of course, is the base, which is also called the growth factor. And here again is the exponent, usually time. And this would work if I said, okay, the newest video game is coming out. You're the first person to show up outside the store. The number of people at the store triples every minute. How many minutes does it take for there to be, now we can say, I don't know, how many minutes does it take for there to be 200 people? So here's a good equation where we could be solving for the minute, and this would be the basic exponential equation that you've been using since Algebra 1. So here, 1 times anything is 1, and if I then wrote this out to say, okay, let me solve this, I would need a log on both sides. So if I throw a log on both sides, I'll have the natural log of 200 is equal to the minutes times the natural log of 3, divide by the natural log of 3. And since I just made this problem up, let's see how long it takes. So natural log of 200 divided by the natural log of 3 tells us it would only take 4.8 minutes for the crowd that's tripling every minute to get to 200. And of course, if you work at Tanger, you see this on Black Friday every year. It is absolutely crazy. All right, basic exponent. Now let's talk about if we have a percent of increase or decrease. So this is my first equation. So now if we have a percent increase or decrease, we have amount over time is equal to the initial amount and 1 plus or minus the interest rate raised up to the time. So again, this is usually in years, unless of course the equation defines the time differently. This is the percentage rate as a decimal. This means 100% of what you had begun with. This is the initial amount. Or the principal. Remember when we did those big loan problems? They called it the principal. And then this is the amount over time. So let's do a problem. Let's just say you bought a car for $15,000. It depreciates, which means it loses value at a rate of 8% per year. I don't know, I'm making this up. So this would be 1 minus the 8% per year. How long will it take for your car to be worth only $10,000? So here was an example. Now, when we did this, we would look at the equation on y1, we would put this on y2, and then we would look to see when the y1 and y2 columns on the tables were the same. And also when we did this, we would make a graph, and we would graph this, and then we would put a straight line through 10,000, and we would use the intersect key. So you've done this before. It does take a little bit of time. And you did this on the other worksheet. So if you've been doing your work, this hopefully is something you're remembering. So here's your 15,000. And 10,000 divided by 15,000 gives me 0.6 repeating. And so that's what I'm going to write on my paper, 0.6 repeating. And this 1 minus 8% means it's keeping 92% of its value raised up to the time. So again, natural log of 0.6 repeating would be the time times the natural log of 0.92. And we divide by the natural log of 0.92. And I would keep that on my calculator, and I would hit natural log of second answer divided by the natural log of 0.92. And I would find out it would take 4.86 years. So let's round that to about 5 years for the car to be worth $10,000. And so these two equations we've spent a lot of time on. Now the other equation that we had to talk about, especially when it came to the mortgage payments, was when we compounded. And when we compounded, it was usually always monthly. But now we're going to see, maybe we compounded quarterly like a savings account. But that equation looked like this. The amount over time is equal to, again, the initial amount. And then we had 1 plus the rate divided by n. Remember this? We had to do this. You guys did an amazing job on those problems because you had the group work that counted as a test, and then you had your take-home test, and the work was phenomenal. And then we said, well, the time is usually in years, but now how many times did we compound? So this now means the number of times we compound per year. And it could be 4, it could be 2, it could be 12 for monthly, it could be 365. You could compound every single day. Notice that these two equations, if you were doing it yearly, anything divided by 1 is this. So this is yearly. You're doing it once a year, but here we would be doing it more than once a year. And so then this is also the number of times per year. Because if you were compounding, say 4 times a year, you wouldn't just have 1 year up here. You would have, I did it this 4 times in 1 year. So let's take a regular savings account. A regular savings account, let's say you put $1,000 into your regular savings account. So now that would be, here's your $1,000. You're keeping 100% of your $1,000. and you're getting a really small, you're only getting 1.5% interest a year. Like, savings accounts are insane. So it's not going to be a lot of money. So let's just see that. 1.5% would be 0.015, and they compound your savings account quarterly 4 times a year. So now there's the 4. The N is there and there. And let's say you leave this money in the bank for, I don't know, how many years. You want to know how long, with just letting this compound, is it going to take for you to make $1,200. So you to earn $200 in interest. So we would have to first take this 0.015. So if you remember, we were really careful with taking our time. Here's the interest rate, 0.015, divided by 4, and we get 0.00375, and then we added 1 to that. We were really careful. And so this gives me now a parenthesis of 1.00375, and this is still 4t up here. And now what I'm going to do is I'm going to divide both sides by 1,000, because we always did that. We want to find out. So we have 1,200 divided by 1,000, and we get 1.2. So now we need logs. So natural log of 1.2 is now equal to, this exponent is going to come down in front, 4t times the natural log of 1.00375. If I'm going to solve now, I'm going to divide by this natural log of 1.00375, and I'm going to hold this division answer, this quotient, on my calculator. So now I'm going to type in natural log of 1.2, and I'm going to divide it by the natural log of 1.00375, and I get 48.710,185, and I'm just going to go 19 because I'm out of room, but I'm leaving it on the calculator. I'm going to divide by 4. So now I'm going to divide this by 4, and I find that the time would be 12.18, or 12 years for me to earn $200 in interest. 12 years, that's crazy. But again, savings accounts, they don't give you a lot of money out of savings accounts. So that was the next one that we did. And then that brings us now to the final one, the final equation, which was compounding continuously. And my really bad joke, which I'm going to make again, this is the guy that you use if you want to scare people on Halloween. Dress up as the PERT formula. So compounding continuously. This is the amount over time is equal to the principal, Euler's number E, raised up to the RT. So let's get a better marker here. So this is the principal. This is E, this is the rate as a decimal. And again, this is the time. So if you were to go on a shopping spree, and let's say you find this, $500 leather jacket that you have to have, and you put it on your charge card, so you're being compounded continuously, and on your interest, you get charged a lot. Let's just say you're getting 25% interest over time, and you take your time paying this off, and how long does it take for this $500 jacket to have cost you, I don't know, $700? Let's see, it's not going to take too long. Let's start with the 700 divided by the 500. This is 1.4. And now this would be e to the 0.25t. Now e is the inverse natural log, just like all our lessons last week. So if I put the natural log on 1.4 and I put the natural log on e to the 0.25t, remember these guys cancel. And this guy like drops down. 0.25t is equal to the natural log of 1.4. So now I'll divide by 0.25. And the natural log of 1.4 divided by 0.25 tells me it only took 1.3 years for a $500 jacket to cost me $700 if I am not making big payments on my credit card. Holy moly. So now what you're going to do is this packet, I am going to attach the author's video as well. Do your best, and I'll take any question you have.